The first type of reaction that we'll look at is a combustion reaction. And a combustion reaction is the reaction with oxygen, O2, to produce common oxides, heat, and light. Another way of saying that it's a reaction with oxygen is to say that it is burned in air. And the reason why that's a reaction with oxygen is because there's a high concentration of oxygen in the air available for combustion. When we react something with oxygen to produce oxides, it depends on what the starting material is to determine what type of oxides are going to be produced. When we say oxides, those are really just compounds of oxygen. The most common type of combustion reaction is to look at an organic hydrocarbon reacting with oxygen to produce carbon dioxide and water. So carbon dioxide and water are the oxides of the hydrocarbon. Oxygen is always available in a sufficient amount, so that means that if you have complete combustion, that means there's plenty of oxygen available. We're going to make CO2 and H2O, and a significant amount of heat and a little bit of light will be produced during this process. If we have incomplete combustion, that means that we're going to produce the same carbon dioxide and water, but we're also going to produce a hazardous compound, carbon monoxide, and also carbon. So it's unable to completely combust, and so we get these toxic materials that are produced. This happens when there's not enough oxygen present. For the most part in this course, when you're asked to do a reaction with oxygen, you can assume that it's complete combustion. So the products are going to be carbon dioxide and water. Carbon-containing compounds make CO2 and H2O, while a sulfur-containing compound would produce SO2 and H2O. That's just to show you that different compounds or starting materials will result in different oxides. And here's an example of a balanced combustion reaction. This is an interesting picture, and we're going to talk more about this type of combustion when we look at synthesis reactions, because the combustion that's happening here, or the reaction with oxygen that's happening here to produce common oxides, can also be viewed as an oxidation reaction. So you can see here, these are the roofs of Parliament in Ottawa, and right now they're preparing for the Canada 150, and so they're cleaning the roofs, and this is a great example showing you the pure copper roofs, and then they're showing you the copper 1 oxide, which is the black, and then the copper 2 oxide, which is the green form of the oxide. And these are technically combustion reactions because they're reaction with oxygen to produce oxides, and so it's producing the copper oxide. But as you'll see later, this can also be viewed as a synthesis reaction. We're going to focus on our combustion, complete combustion of carbon-containing compounds, and here are a few tips to pay attention to when you're balancing. You want to first balance the carbon, then the hydrogen, then the oxygen. And if you run into trouble with balancing, you're going to put a 2 in front of the carbon compound. So we'll see what happens here. We have C3H8 plus O2. So we have a carbon-containing compound reacting with oxygen. So we know we're going to produce CO2 and H2O. We're going to balance the carbon first, and then the hydrogen. So there are 8 hydrogens, so I'm going to put a 4 on this side. And then I'm going to look at the oxygens last. So I'm going to tally up the oxygens on the right hand side. So I have 6 plus 4 for a total of 10. Therefore I need a 5 in front of the oxygen. For this one here, it's a different looking compound, and what we learn later when we study organic chemistry further is that the way that we draw molecules or write molecules helps us to draw them. So we don't really need to worry about it, but we just need to pay attention to the total number of atoms. So we have 6 carbon atoms. We have a total of 14 hydrogens, so that's going to give me 7 hydrogens on this side, 7 waters, my apologies. So when I'm tallying up the oxygens, I have 12 plus 7 for a total of 19. I have 1 oxygen here, so I have 18 left, so I need a 9 in front of the oxygen. My last one here, butanol, is burned in air. So like I said earlier, burning butanol in air is reacting it with oxygen. Because it's a carbon-containing compound, I'm going to produce CO2 and H2O upon combustion. I have 4 carbons, 10 hydrogens, for a 5 here. I have a total of 8 plus 5 on this side, which gives me 13. I have 1 oxygen in that compound, so therefore I need 12 from my O2, so I'm going to have a 6 there. And that concludes this video on combustion.